In a previous video talking about subatomic particles and atomic structure, I mentioned how atoms can have different numbers of neutrons. And that was really important because that resulted in isotopes. And these were atoms of the same element that had different mass numbers because they had a different number of neutrons. Because the neutrons and the protons were the two subatomic particles that told us what mass an atom has. Now, neutrons are not the only subatomic particle that can change. What's important to remember is that it's not the protons. The protons always stays the same because that tells us what element it is. And it's not the neutrons because, well, we've already spoke about those. That would give us isotopes with different masses. But the third and final subatomic particle that we're going to talk about changing is the electrons. So we're going to talk about something called ions. So atoms, as well as being able to have different numbers of neutrons, can actually lose or gain electrons as well. And they do this to become more energetically stable, which I'll talk about in a little second. But the important part is that the newly formed particles, as a result of this change, as a result of losing electrons or gaining more electrons, are called ions. So if I lose even one electron or gain even one electron or more, I am no longer an atom because I don't have the same number of protons and electrons anymore. Okay? If that happens, if the electron number changes, then the charge is going to change from 0 to either be positive or negative, because that balance of positive protons and negative electrons has changed. They're not an even number anymore, they're not an equal number anymore. And that mismatch, that different number of electrons to protons, means that the atom has become an ion. So why does it do that? Why does that happen? Well, the two main reasons are atoms really want to be like the noble gases. So thinking back to the periodic table, we have a few main groups that were very important to remember. I spoke about the alkali metals, I spoke about the halogens in group 7, and I spoke about the noble gases right at the end. And we either called that group 8 or group 0. Now, why is this important? Because elements that are in this end group, this group 8, all have a full outer shell of electrons. So in the previous video, we spoke about electrons and electron arrangements. If you haven't seen that, go watch that first. But the main point is, everything in this group, all of its atoms, all of these elements' atoms, their outer electrons, the shell that they occupy, or the orbital that those electrons occupy, are all fully filled. They're all full. So all the other elements in the periodic table want to be like that because it's stable. It's a really stable, energetic arrangement because they have full outer orbitals. So noble gases are the ones to be like because they are stable. So we're going to learn a bit more about this by looking at two main examples. We're going to look at what happens when electrons are lost and why that might happen. And then we're going to look at what happens when electrons can be gained by an atom as well. So we're going to start off with an example of a metal, calcium. And calcium reacts, like all or most metals do, by losing outer electrons. So what does this look like? Well, I've drawn out, first of all, an atom with the nucleus with protons and neutrons inside, and then the electrons are orbiting the nucleus as I demonstrated in the previous video. So they fill these energy levels called orbitals in a very exact way. It's not random, they're all organized. So in this case, there are 20 electrons. So that means we need 1, 2, 3, 4 total orbitals to fill in all of those electrons. So what happens? Well, in certain reactions, calcium will lose this electron here and this electron here. Now, why those two? Why not the two in the middle, or some from the inner orbitals. Well, these electrons on the outside are the first electrons that other substances are going to come into contact with. They're the easiest to pull off because they're on the outside. These are the ones that things come into contact with first. So they're the first ones that are going to be lost. It's always the outer electrons that we want to consider when we're thinking about reactivity or chemical reactions, or really any kind of chemical change in elements or atoms. It's the outer electrons that do all the work, if you like. So what happens is these two electrons are removed or pulled off or donated to something else in some kind of reaction, and we are left with two less electrons, which means we don't even need to draw in that fourth shell anymore. It's not needed because those electrons are no longer orbiting this atom's nucleus. So they're away doing something else. They've reacted, and we're left with this. Now the question is, what charge does this substance, this particle, now have? Well, if it's lost some negativity, it now has more protons than it does electrons, meaning I have formed a positive ion. I've went from being neutral, 20 protons, 20 electrons, to having a positive charge, because I've still got 20 protons, but now I've only got 18 electrons. These other two have left to go and react with something else. So if I lose electrons, I form a positive ion, and that is very important to remember. So losing negative electrons forms a positive ion. And very importantly too, we can no longer call this thing on the right hand side an atom. It's not an atom anymore because it's not electrically neutral. It does not have the same number of protons and electrons, so it's now an ion. And it's a positive ion because it's lost electrons. And the way that we show that is by a little plus in the top right hand corner and a number in front of that plus, in front of that symbol, to show how many positive charges. Since it's lost two negatives, we're going to have to fill it in with two positives to show that it has a 2 plus charge overall. So that is the first example. The second example is what happens when the opposite happens. Because it's not just that electrons can be lost, they can also be gained, again, through some kind of reaction. It's mainly non-metal atoms that do that. So we're thinking about the right-hand side of the periodic table now. So non-metal atoms react by gaining outer electrons. So for example, we could talk about chlorine. So I've done the same thing again, drawn out a full diagram of chlorine with my 17 protons in the middle and my 17 electrons around the outside. And this time, let's think about what is happening, because again, we have outer electrons and we have some kind of reaction happening. Now you could say, well, why doesn't the chlorine just lose electrons? Why don't all atoms just lose electrons? Why don't they all just gain electrons? Why don't they all do the same thing? Well, let's have a look at the outer electrons in chlorine's case and compare it with what we saw before in our calcium example. So this time we have not just one or two outer electrons, but 1, 2, 3, 4, 5, 6, 7 outer electrons. Now, removing an electron or gaining an electron isn't free, right? There's some energetic cost that happens. So ripping off an electron from an atom, which some other chemical will come along and do, is not cheap. It costs energy. So which do you think would be easier to do? To remove 2 electrons from an outer shell, like we did with calcium, or to remove 7 outer electrons? Well, of course it's going to be the calcium example. It would be much more difficult to remove all of these 7 outer electrons. But chlorine is still in a predicament, it's still in a problem, it still wants to be stable. It still wants to have a full outer shell of electrons. So how's it going to do that? Well, it's not going to remove all of these outer electrons. It's going to gain an electron from somewhere else. It's going to react with another chemical that can donate its electron to chlorine, and chlorine will tear it off of something else. It will steal it. So instead of losing its outer electrons, it gains one, and now look what's happened. Now chlorine has 1, 2, 3, 4, 5, 6, 7, 8. Perfect. It now has a full shell, a full outer shell of electrons. So in both cases, the calcium ion is now more stable, because in losing that outer shell, it now has a full outer shell. If you go down to the next layer of orbitals, it's got 1, 2, 3, 4, 5, 6, 7, 8. Good. It's stable. And the chlorine, by doing the opposite, by gaining an electron, now has 1, 2, 3, 4, 5, 6, 7, 8. A full outer shell, a full outer orbital of electrons. So the calcium ion and the chlorine ion are now more stable as a result of either losing or gaining electrons. And we do a very similar thing to show that reaction when we gain electrons. We draw our atom, which is just the chemical symbol with no little symbols at the top. What's happening with the electrons? In this case, we are gaining an electron, so we're adding it on. And the result is the opposite of what happened before. We now have a negatively charged ion because this particle has more electrons than it does protons. It has 17 protons, but now it has 18 electrons. So it's got one negative charge. And notice before we drew a little number 2. If there's anything in chemistry that we need to draw a 1 for, we just leave it out, because it's implied that there is 1 there because we've drawn a little symbol. So 1 chlorine, 1 electron, 1 chlorine. We don't draw number 1s next to these. If there's a number 1, we just leave that part out. So it's just 1 negative by drawing just the negative sign on its own. So negative ions formed because we've got 1 more electron than we do protons. And that's, again, important to remember. So if we gain negative electrons, we form a negative ion, because now we've got more negativity than we do positivity. So just to summarise, ions are charged particles formed when atoms lose or gain electrons. And they do this so that the atoms can become more stable. So they want full outer shells or full outer orbitals of electrons. And in doing so, they either lose or gain electrons. If they gain electrons, they have become more negative. So they form negative ions. And if they lose electrons, if they lose negative particles, they become positive ions, positively charged ions.